How do we know the universe is expanding? It's a strange question because it assumes something almost impossible to picture. Expansion of everything, not just galaxies drifting apart, not just stars pulling away, but space itself stretching like an invisible fabric tugged from all sides. You might try to imagine it, galaxies like lanterns carried out into darkness, but immediately the mind protests. Expanding into what? Expanding from where? And yet somehow scientists claim they can measure this. They speak of evidence written in light, of patterns in the sky that whisper a story of motion. But how can such a thing be proven when you can't step outside of the universe to watch it grow? You sit with the question, letting it breathe. It lingers like a riddle, half maddening, half magnetic. Because if this is true, if the universe itself is stretching, then everything you know is shifting beneath you, silently, invisibly. The ground feels still. The sky above looks calm, and yet they say the very stage on which you exist is pulling apart in all directions. To understand it, you need to let your imagination stretch as well. Imagine a balloon half inflated. Dots are drawn across its surface, scattered like tiny galaxies. As the balloon swells, the dots drift farther apart, though none of them are moving on their own. The surface itself, the space in between, is what grows. But even this picture is a cheat because a balloon expands into the air around it, into something else. The universe, as far as we can tell, doesn't have an outside. There is no air into which it swells. The stretching happens within itself, silently, with no beyond. It's not surprising your intuition resists this idea. Humans evolved to sense changes close to home, the rustle of branches, the rhythm of waves, the cycle of day and night. You can see a shadow lengthen, hear the pitch of a train as it passes, feel the ground tremble with thunder, but cosmic expansion, that is not built into your instincts. The distances are too large, the timescales too long. From Earth, looking up at the stars, it seems as though nothing moves at all. The constellations have burned their shapes into the sky for thousands of years, unmoving, dependable. The illusion of stillness is strong, and yet beneath that illusion, the story of motion is written, hidden in the light. Every star, every galaxy sends out photons, tiny messengers racing across the void, and those messengers carry secrets. They tell of speed, of direction, of distance. They encode the fingerprints of expansion. The trick is learning how to read them. That is where science begins, not with certainty but with a question. How do you measure what seems unmeasurable? How do you glimpse the movement of the universe when you are locked inside it with no vantage point beyond its walls? For centuries, philosophers and astronomers wrestled with this. Some believed the universe was eternal, unchanging, infinite. Others imagined a cosmos that might grow or shrink or cycle endlessly through ages. Each view was bold, each was limited. The evidence had not yet spoken, but over time instruments sharpened, scopes became eyes stretched further and further into the dark, and the stars, which once seemed mute, began to whisper. Subtle shifts in their light carried clues, the wavelengths stretched or compressed. Some stars glowed faintly redder than expected, some bluer. It was as though the universe itself was trying to tell a secret, one that required patience to decode. Here the strangeness deepens, because the universe doesn't announce itself in thunderclaps or visible ruptures. Its expansion isn't something you can sense with your skin or your breath. It is quiet, almost invisible, revealed only when you stack centuries of curiosity on top of one another. Each scientist, each generation added a piece, and together the picture began to emerge. The cosmos was not static. It was restless, dynamic, alive with motion. Still, the mind resists. You picture galaxies receding, stars drawing apart like lanterns carried by invisible currents. But where does it end? If everything is moving away, does that mean we are at the center? And if we are not, then how can expansion look the same from every point? These are not foolish questions. They are the right questions. They are the ones scientists themselves had to face. And perhaps the deepest puzzle of all, if the universe is expanding, does that mean it was once smaller? Was there a beginning, a single instant when all of this, the galaxies, the stars, the space between them, was compacted into something unimaginably dense? The idea feels too dramatic, too mythic. And yet expansion points backward like a trail of footprints fading into the distance. If you follow them far enough, they converge, not at a place but at a moment. You pause here because the weight of that possibility is almost too much. A beginning of the universe. A moment when time and space themselves came into being. If expansion is real, then the story of everything is not eternal. It has an origin. And so you lean closer to the evidence. You ask again, how do we know? What did we see? What convinced us that the universe is swelling outward, carrying galaxies on its tide? The answer lies in the light, and in the patience of those who first learned to listen to it. You left off with the thought of light, those tiny messengers crossing the void, carrying secrets about the universe's motion. To follow the thread, you need to slow down and think carefully about what light really is. Because it is so easy to take it for granted. The glow of a candle, the glare of a screen, the warm spill of the sun across your skin. Light feels ordinary, familiar, almost transparent in its presence. And yet hidden in each wave, each photon, is a record of where it came from, how it has traveled, and what it has passed through. Every beam of starlight is a letter written across time. Some of those letters began their journey before Earth even existed. And when you look up at the night sky, you are not simply seeing stars. You are reading their messages. The first step toward knowing the universe is expanding begins with reading those messages carefully. Imagine yourself as an ancient scribe holding fragments of clay tablets in your hands. The writing is faint, broken, incomplete, but if you study the marks long enough, you begin to sense a pattern, a voice from long ago. That is what astronomers do with light. They break it apart, study its frequencies, tease out the subtle distortions. And hidden there in the very stretch of the waves lies the signature of cosmic expansion. But before the discovery, there was doubt. For most of human history, the heavens were assumed eternal, unchanged. Aristotle once declared the universe had no beginning, no end. It simply was, a grand stage, fixed and perfect. That belief held for centuries, reinforced by the constancy of the stars. You could live an entire lifetime, pass the sky to your children and grandchildren, and nothing seemed altered. The constellations did not drift. The heavens did not unravel. The illusion of permanence was absolute. Then came the telescope. For the first time, faint smudges in the sky became something more than imagination. Galileo saw the moons of Jupiter circling like miniature planets. Later, others discovered faint patches of light scattered across the firmament, nebulae, galaxies, clusters of stars beyond count. The universe was larger, stranger than anyone had guessed. And yet still the assumption lingered. Perhaps it was infinite, timeless, without beginning or end. And here is where curiosity sharpened into obsession. Astronomers began to notice something peculiar about the light from these distant stars and galaxies. When passed through a prism, the light broke apart into bands of color. And within those bands were fingerprints, lines where certain colors were missing, absorbed by the elements inside the star. Hydrogen, helium, carbon, all leaving their marks like familiar signatures. But those lines did not always appear where they were expected. They shifted. Sometimes slightly toward the red end of the spectrum, sometimes toward the blue. This shift was not random, it carried meaning. Because here on Earth, scientists had already learned something about sound and motion. You know it instinctively, though you may not name it, the Doppler effect. A train whistle approaching grows higher, shriller. As it passes, the tone drops away. The sound waves compress as the source approaches, stretch as it recedes. Light behaves in the same way. When a star or galaxy moves toward you, its light shifts toward blue. When it moves away, it stretches toward red. This realization was like a crack in the shell of the old worldview. Suddenly, astronomers had a way to measure motion not through direct observation, but through color. A subtle bending of light became a cosmic speedometer, and when they began to use it, the results were astonishing. Galaxy after galaxy showed the same pattern. Their light was shifted toward the red, not just one or two, not just in a single corner of the sky. Almost everywhere they looked, the story repeated, receding, receding, receding. Each one seemed to be fleeing, as if the universe itself were unraveling outward. But before the conclusion was drawn, confusion reigned. Surely this couldn't mean the whole cosmos was expanding. Perhaps the data were flawed or the interpretation mistaken. Maybe the galaxies had peculiar motions, wandering in strange patterns, or perhaps light itself changed as it traveled, its waves stretched by some unknown process. Doubt is natural in science and necessary. It prevents leaps too far, too fast. And yet, as more data arrived, the doubts began to crumble. The redshift was not random. It followed a law, a precise relationship. The farther away a galaxy appeared, the greater its light was shifted toward red. Near galaxies moved a little, distant galaxies moved a lot. The pattern was unmistakable, like a drumbeat echoing across the sky. The universe was expanding. The stage itself was growing. You pause here, feeling the weight of the revelation, Because even though you can follow the logic, something inside you still resists. Expansion is not a thing you can see directly. You look around your room, nothing stretches, nothing grows. You look up at the stars, unchanging, eternal in appearance. And yet, hidden in the light, the truth is there. The illusion of stillness hides a restless cosmos. Think of it this way. Imagine sitting at the shore, watching waves lap against the rocks. To your eyes, the water may seem still in the distance. The horizon looks calm, a flat band beneath the sky. But if you wait, if you pay attention, you notice the rhythm. Swells rise, currents shift, foam gathers and dissolves. The ocean is never still, even when it looks that way. The universe is like that, motion disguised by scale. Expansion too vast, too slow for daily senses to detect. And so we return to the question, how do we know? We know because the light tells us so, patiently, faithfully, from millions and billions of years away. It is as if the galaxies themselves are shouting across the void. We are moving apart, we are drifting, the universe is growing. This realization is only the beginning, because once you accept expansion, another question rises, more difficult, more haunting. What does this mean for the past? If galaxies are moving apart now, then once long ago they must have been closer together. Trace the motion backward and the distances shrink. Trace it far enough and everything converges, not at a point in space but at a point in time. A beginning. A universe that was once impossibly dense, impossibly hot, impossibly small. That thought will wait for later. For now, stay with the first discovery. The universe is expanding, and we know it not from imagination but from light. The evidence is subtle but clear. A shift of color, a stretching of waves, a drumbeat of motion encoded in the sky. You lean back, letting the thought settle. Somewhere far away, a galaxy drifts a little farther from view. Its light stretches just a little more toward red. You cannot feel it, you cannot see it, but you know it is happening right now everywhere. And the question echoes forward. If everything is expanding, then what becomes of the future? The universe is expanding. That realization now rests before you, undeniable, carved into the fabric of observation. It was not guessed, not invented, not dreamed into being. It was measured. Starlight, stretched into red, whispered its secret to patient eyes. But knowing is not the same as understanding. You can accept the evidence and still feel bewildered, even unsettled, because the claim does not only concern galaxies far away, drifting silently across unimaginable distances. It concerns you here now in the quiet of the space you inhabit. The very air between your hands, the very darkness between atoms participates in this expansion. You are living inside it, like a fish inside an ever-widening ocean. And yet, if that is true, why do you not feel it? Why does your room not swell? Why does the distance between the chair and the wall not stretch in slow increments? If the fabric of space is expanding, shouldn't everything expand along with it? The puzzle digs deeper. You want to believe because the evidence says you must, but your intuition resists. Part of the answer lies in scale. Expansion is not like a balloon rising suddenly in your hands, not something you could ever watch in real time. It unfolds across millions of years, distances so vast they defy imagination. Galaxies far apart feel the tug most strongly. The gravity of smaller systems, stars, planets, even clusters of galaxies binds them together, resisting the cosmic swell. The Earth does not drift from the Sun because their bond is stronger than the expansion around them. Your atoms do not dissolve into emptiness because the forces that hold them together are fierce beyond measure. Expansion works on the great canvas, not the fine strokes. It is a story told at the scale of universes, not rooms. Still, the knowledge changes something inside you. The world feels less solid, less permanent. The sky above no longer seems still, but alive, restless. You imagine galaxies as ships adrift, each carried outward on an unseen tide. No oars, no engines, no sound, just the silent current of space itself stretching beneath them. This realization does something more than shift your scientific understanding. It alters your sense of time, because expansion is not static, it is a process. If the universe is larger now than it once was, then it is also older. If it is growing now, it must have grown before. Every moment is not simply passing, but stretching the very arena in which moments occur. The present is not just a dot in time, it is a ripple across an ever-widening pool. And if you can follow that thought backward, as astronomers have, the pool narrows. The galaxies converge, the distances shrink, until you find yourself at the edge of a great mystery. A universe once gathered together, impossibly dense, impossibly hot, a beginning written not in myth but in physics. The first people to glimpse this possibility must have felt the same vertigo you feel now. When Edwin Hubble measured the redshifts and plotted the distances, he revealed not just a law but a vision of reality that shattered the static universe. Space was not fixed. Time was not endless in both directions. The universe had a history, and by implication, a future. For many, this was a shock. It was easier, perhaps, to imagine a universe eternal and unchanging. Such a cosmos asked fewer questions, but once expansion was uncovered, there was no returning to stillness. The door had been opened. The universe was a story in motion. You pause to consider what this means for your own existence. The light from distant galaxies has traveled for billions of years to reach your eyes, and all the while the space between has stretched. You are seeing them not as they are now, but as they were long ago, caught in a younger universe. The night sky is not a portrait of the present, but an archive of the past. Every glance upward is a kind of time travel. You might picture it this way: imagine standing on a hill looking across a valley. In the far distance, lightning flashes, but the thunder does not reach you until long after, carried slowly through the air. What you see and what you hear are separated by distance and delay. The cosmos works in a similar way. The farther you look, the further back in time you see. The expansion stretches that distance, stretches the delay. You are forever glimpsing the history of the universe, never quite its now. This is one of the quiet paradoxes of existence. You live in the present, and yet everything you observe is already past. The stars you see may no longer exist. The galaxies may have drifted far from the positions you assign them in the sky. You live surrounded by ghosts of light, and the expansion ensures those ghosts grow older and fainter as they cross the widening gulf. The thought can be dizzying, even a little melancholy, but it can also be grounding. To know you are part of a story that began billions of years ago, still unfolding, still stretching, is to realize you are not just a bystander. You are woven into it. The atoms of your body, the air you breathe, the ground beneath your feet, all are caught in this expanding tide. You belong to it inseparably. Still, the mind presses back with another question. If the universe is expanding everywhere, why does it look the same from here as it would from anywhere else? If galaxies are receding in all directions, doesn't that make Earth the center? Isn't that the implication? It feels counterintuitive and unsettling. But no, this is where expansion defies simple intuition. Because there is no center, expansion is not galaxies flying away from a single point. It is the stretching of space itself everywhere at once. Imagine standing on the surface of that balloon again. No matter where you place yourself, the dots around you recede. To any observer, the pattern looks the same. That is the trick of the cosmos. Every vantage point tells the same story, not because we are privileged, but because expansion is uniform. This, too, was a revelation. It meant Earth was not at the middle of anything, nor was the Milky Way, nor any galaxy at all. Every point in space is equally part of the expansion. The universe has no edge, no center, no privileged vantage. It grows everywhere, from everywhere into everywhere. You sit with this thought, letting it ripple outward, because the more you think about it, the stranger it feels. To live in an expanding universe is to accept that even the most basic instincts, up, down, here, there, fail at cosmic scales. You cannot point to the middle. You cannot ask what lies beyond. The words themselves dissolve in the silence of the infinite, and yet you are not left with emptiness. You are left with a story written in light, unfolding across billions of years, stretching outward like a quiet breath. You wonder quietly if there is any other truth more humbling than this. You exist inside a universe that is not finished. It is still becoming, and you are alive in the middle of its becoming, able to know, to measure, to wonder. That is the gift of the question you began with. How do we know the universe is expanding? We know because the evidence spoke patiently, relentlessly, until the silence broke. And now the silence carries a different weight. You are surrounded by a cosmos in motion. And the next step, the harder step, is this: to confront how deeply this defies your intuition, to admit that the way you imagine space, the way you imagine stillness, is incomplete. Expansion does not simply stretch the universe, it stretches the mind. You know the universe is expanding. At least you know the evidence says so. The light shifts, the galaxies recede. The pattern repeats with mathematical precision. But there's a problem, a quiet resistance that lingers in the mind. The evidence may convince the intellect, yet the intuition rebels. Because everything you know about motion, about space, about growth, tells you expansion should look different, it should feel different. If the fabric of reality is stretching, you expect to see seams, to notice change, to feel a subtle drift in your daily life. But you don't. The desk before you holds its shape. The air in your lungs does not thin as the universe grows around you. When you walk across the room, you do not feel as though you are walking uphill against a current. Expansion leaves no trace in the body. It exists at scales so great that it slips beneath the skin of perception. And yet your intuition whispers protests. How can space itself expand? Expansion is supposed to happen into something else. A balloon swells into the air, a drop of ink spreads into water, a sound radiates through silence. But if the universe is expanding, what lies outside of it? What is it growing into? Your mind searches for an image, a metaphor, a container, but every metaphor cheats because the universe is not in anything. It has no beyond, no outside. Expansion occurs not into space, but of space. The stage grows larger, but there is no theater around it. This feels impossible, and that is the point. The very language you use, inside, outside, beyond, is built from experiences too small for the cosmos. You evolved to navigate forests, rivers, villages, not the stretching of space-time. Intuition is bound by survival. It cannot scale to infinity. So you wrestle with images. You picture galaxies as dots on a balloon. That helps a little. You can see them drift apart as the surface stretches, but even there your mind cheats. The balloon swells into air. You imagine standing outside watching. The metaphor betrays you. The truth is harder. There is no outside vantage. The universe does not expand into anything. It is not a balloon floating in a room. It is all that is. The stretching occurs within itself. And here your intuition resists again. If everything is expanding, why don't we notice it on small scales? Why aren't you and I drifting apart as we sit here? Shouldn't the atoms of your body be swirling, pulled by the cosmic tide? But the answer lies in forces, in balance. Gravity binds planets to stars, stars to galaxies. The electromagnetic force holds atoms together. These local bonds are far stronger than expansion. The universe stretches only across the gulfs too wide to resist. Between galaxies, expansion wins. Within galaxies, within solar systems, within bodies, it loses. The cosmic tide whispers too faintly to break what is tightly bound. Still you struggle, because when you picture galaxies fleeing, it feels like they must be rushing through space, like rockets flying away from some central point. But that too is a trap. Expansion is not motion through space, it is motion of space. Galaxies are not engines burning fuel, sprinting outward. They are like boats carried on a rising tide. They drift apart not because they are moving, but because the ocean itself grows beneath them. Your intuition does not like this. It insists on a center. Surely somewhere there must be an origin point, a place from which all else recedes. But expansion laughs at this craving. From every vantage, the story looks the same. Stand in the Milky Way, galaxies recede. Stand in Andromeda, galaxies recede. Stand anywhere, galaxies recede. The universe has no privileged middle, no anchor, no still point. Expansion is democratic, impartial, everywhere at once. And then another protest rises. If the universe is infinite, how can it expand? Infinity cannot grow larger, it already contains everything. This too feels like a paradox, and yet mathematics untangles it. The universe may be infinite in extent, but still the distances within it can increase. Imagine a number line. It stretches endlessly in both directions, and yet you can take any 2 points and pull them apart. Infinity expands not by becoming more infinite, but by increasing the separation between what is already there. But there's another possibility. Perhaps the universe is not infinite. Perhaps it is vast but finite, curved upon itself like the surface of a sphere. In that case, expansion is easier to imagine. The fabric swells, the total volume increases. No edge, no beyond, just endless curvature widening. But here intuition resists again because you cannot step outside to see the shape. You can only measure from within, trace the patterns, infer the geometry. To live inside the universe is to be forever denied the outside view. You will never see the whole balloon. And this is where the brokenness of intuition becomes sharpest. You live in a cosmos whose rules do not match the instincts of daily life. Expansion is real but invisible, universal but untouchable, measurable but incomprehensible to raw senses. So you turn inward and ask, what does it mean to trust evidence over intuition? To let light, not instinct, guide you? Science has always asked this. The earth feels flat, the sun feels like it revolves around you, motion feels like it needs a push to persist. Intuition says so, and yet all these intuitions were broken, overturned by evidence. The expanding universe is only the latest fracture in the familiar. Another reminder that the cosmos does not care what feels natural to human thought. But there is beauty here hidden in the fracture. To live in an expanding universe is to be reminded that reality is larger than perception, stranger than instinct, richer than imagination. You are stretched too, not your atoms, not your body, but your mind, forced to grow into shapes that feel impossible. And yet the impossibility becomes part of you. You begin to live with it, to breathe it. Expansion stops being a concept and becomes a lens through which you see the sky. Stars no longer feel still, galaxies no longer feel fixed. Every night becomes a reminder of motion too vast to feel, too slow to witness, yet undeniably real. And the more you sit with it, the more the paradox softens. Expansion no longer feels like something happening far away. It feels like a condition of being. The universe is not a place. It is a process, not a container, a becoming. This is the brokenness of intuition, but also its repair. You cannot make the universe simple, but you can learn to let it be strange. And so the question lingers. If your instincts fail at cosmic scales, how far can you trust them? What else in the universe hides truths that intuition alone will never grasp? You've accepted, at least in thought, that the universe is expanding. You've even acknowledged that your intuition protests, pulling against the evidence like a stubborn weight. But the protests keep returning. They multiply. They insist on being heard. Because the universe is supposed to feel solid, dependable. Space is supposed to be empty, unchanging. It's the backdrop, not the actor, the stage, not the play. When you picture motion, you imagine objects moving through space, not space itself changing. And so when scientists say the fabric of reality stretches, your mind rebels. A fabric, woven of what? Stretching how? You look around and nothing seems to support the claim. A ruler in your drawer measures the same length as yesterday. A table keeps its dimensions. Your neighborhood does not grow larger with the passing years. Expansion, if it exists, hides itself with remarkable subtlety. So your first protest rises again. If the universe is expanding everywhere, why don't we notice it here? The answer is simple but not satisfying. Expansion only dominates where nothing else is strong enough to resist. On the grandest scales, between galaxies, between clusters, gravity weakens and the swell of space takes over. But within a galaxy, gravity binds stars into spirals and clusters. Within a solar system, the sun holds its planets close. On Earth, gravity clutches oceans and mountains alike. Even in your body, electromagnetic forces pin atoms together. Expansion cannot pry them apart. Its grip is too weak in the presence of stronger bonds. So expansion is real but only visible in the vast emptiness between galaxies. It is everywhere but not everywhere equally. You live in the middle of a cosmic balance, bound tightly enough to resist, but not so tightly that the universe stands still. You are spared the feeling of expansion because you are held fast by local bonds. And yet the protest remains. If space stretches, surely something must stretch into it. Surely there must be an outside, some backdrop into which the universe unfurls. Your imagination craves this. You picture the balloon again. You picture ink spreading in water, a drop diffusing outward. But these are traps. The universe is not in anything. It does not sit inside a larger room. There is no beyond. Expansion is not a pushing outward into emptiness, but a swelling from within, everywhere at once. This thought is so alien that your intuition breaks again. You want to climb above it, to see from outside, but there is no outside to climb to. You want to point to a center, but there is no center to find. Expansion laughs at these instincts. It asks you to hold a vision that feels impossible, a fabric with no edges, a growth with no container. And then comes the third protest, the one that feels like a riddle. How can an infinite universe expand? If it already contains everything, what does it mean for it to grow? Infinity plus something is still infinity. How can the largest possible thing become larger still? The answer lies in separating size from separation. Imagine a number line stretching endlessly in both directions. It is already infinite, but take 2 marks upon it, say 0 and 1, and imagine the distance between them stretching to 2 to 10 to 1,000,000. The line is no more or less infinite than before. but the space between chosen points grows. Infinity expands not by becoming larger, but by altering the distances within. This explanation works mathematically, but intuition still squirms. Numbers are abstract, the universe is not. You want a picture you can feel, so you turn to another image, a loaf of raisin bread rising in the oven. As it swells, the raisins move farther apart. None of them is special, none is central. Each one sees the others recede. If the bread were infinite, the same would be true. Expansion is not about edges, it is about relations. Even this, though, is unsatisfying, because in the end bread rises into air, into a kitchen, into a world beyond. And the universe, again, has no such beyond. It contains its own rising, its own stage. The metaphor holds, but only halfway. And perhaps that is the best intuition can do, halfway. This is the lesson of broken intuition. The mind was not built for the cosmos. You evolved to gauge the arc of a thrown stone, the bend of a river, the length of a shadow. Those instincts serve survival, but they fail against infinity. Expansion is one of those failures. It does not fit the shapes your thoughts expect. But here is the strange beauty. Broken intuition is not the end of understanding. It is the beginning. Each time instinct is wrong, evidence pulls you further. The earth feels flat, evidence says it curves. The sun feels like it circles the earth, evidence says otherwise. Motion feels like it requires force, evidence shows inertia carries it. And now space feels still, evidence says it stretches. Again and again, intuition breaks and the cracks let light through. So perhaps you begin to trust this strangeness, to accept that if the universe feels wrong, that is no failure of the universe. It is a failure of your scale, and maybe, just maybe, that failure is a gift, because what is awe if not the feeling of being broken open by something too vast to fit inside your instincts? You sit with that thought, expansion becomes less of an absurdity and more of an invitation, a reminder that your mind is not the measure of all things. The universe does not shrink to fit your sense of normal. Instead, you are asked to expand with it, to stretch imagination until it bends, warps, and finally allows the impossible to settle in as truth. And once you begin to live with this truth, everything shifts. The stars no longer seem fixed but receding. The galaxies are no longer silent but singing, each note a redshift, each vibration a clue. You start to sense that you are not standing on solid ground in a static cosmos, but riding a tide, drifting outward on an ocean that grows beneath you. The protests do not vanish, they never will. Some part of you will always resist, always crave a center, an edge, an outside. But you can hold that craving gently, the way you might hold a child's insistence that the horizon is the end of the world. You can know it is wrong and still honor the feeling. Intuition is not an enemy, only a smaller truth. And so at last you arrive at a delicate balance, trusting the evidence while carrying the strangeness. The universe is expanding though you cannot see it. Space is stretching though you cannot feel it. Galaxies are receding though the stars above seem fixed. And in that dissonance you begin to glimpse what it means to live in a reality larger than instinct. This is where science does its finest work, not in confirming what feels obvious, but in revealing what feels impossible. To know the universe expands is to know that truth is not limited to comfort. It is to know that the cosmos is free to be strange. And with that acceptance comes the next question. If intuition fails here, what else might it fail to grasp? What deeper mysteries wait beyond even this, waiting to fracture your sense of the possible once more? Your intuition has been tested. It has bent, stretched, and fractured under the weight of expansion. But still it resists, still it whispers questions that refuse to dissolve. How can you live in an expanding universe and not feel it? How can a cosmos with no edge expand at all? How can something infinite become larger? And if everything is rushing apart, what holds meaning together? These are not foolish doubts. They are the natural echoes of a mind tuned for smaller scales. Expansion is too vast, too slow, too alien. It does not match what eyes see or hands touch. So the brain does what it always does when faced with strangeness. It tries to make the unfamiliar fit into familiar shapes. You reach for metaphors again and again. the balloon with its dots, the loaf of raisin bread rising, the ink drop spreading in water. They help but never fully. Each metaphor cheats, sneaks in an outside container that the real universe does not have. The balloon swells into air, the bread rises into an oven, the ink disperses in a glass, but the universe, it has no container, it does not swell into anything, it swells within itself. And this is where the deepest fracture in intuition lies. Because every experience you've ever had of expansion has an outside. Rooms expand into hallways. Rivers flood into fields. Sound travels into air. Nothing in your daily life prepares you for a growth without a beyond. Your imagination claws at the edges, demands to know into what, but the truth remains into nothing, or more precisely, not into at all. Expansion is not movement through space, it is space itself changing. You try to picture it, you close your eyes, see galaxies floating like fireflies in darkness. You imagine them drifting outward, carried by a tide you cannot see, but immediately the old craving returns. You place yourself outside, watching from a distance, seeing the whole show at once. The imagination cheats again because you cannot step outside. There is no balcony above the cosmos, no theater where you can sit and watch the stage. You are trapped inside the play along with everything else. This is what makes expansion so hard to grasp. It is not only counterintuitive, it is unvisualizable. Every picture you draw betrays you. The balloon, the bread, the fireflies, all of them smuggle in an outside you know doesn't exist. And yet without those metaphors, you are left with nothing but equations, abstractions, symbols written in the language of mathematics. So your intuition fractures again. You are forced to accept a truth you cannot see, cannot feel, cannot truly picture. You must learn to live with the paradox, an expanding universe with no center, no edge, no outside. A growth that occurs everywhere at once, not into anything but of everything. And then another protest rises, quieter but sharper. If everything expands, how do we measure it? Doesn't our measuring stick expand too? Wouldn't rulers grow longer, clocks tick differently, atoms themselves stretch along with space? If so, how could we ever notice? It is a haunting question because it seems to undo the very possibility of proof. If everything grew together, all distances preserved, then expansion would be undetectable. But here lies the distinction. Expansion does not act on bound systems. Rulers, atoms, clocks, these are tied together by forces stronger than the cosmic swell. They do not expand, they hold. And because they hold, they can measure what does not. Galaxies, too far apart to bind, do drift. Their light stretches, their signals shift. And we can see it, even if we cannot feel it. The protests don't end there. Some whisper of relativity. If everything is moving away faster and faster, does that mean some galaxies recede faster than light? Does that not break the rules? Again, intuition balks, but relativity is subtler than instinct. Nothing moves through space faster than light, but space itself can expand at any rate, and the galaxies it carries can recede as swiftly as the expansion demands. The rule holds, but in a way that defies your sense of what motion is. And then the strangest protest of all emerges. If the universe expands now, did it always? Will it always? Could it stop, reverse, collapse back upon itself? Or does it stretch forever, thinning into silence? Your mind cannot help but jump ahead, imagining ends before beginnings are even clear. But pause here, stay with the discomfort of the present, stay with the fracture in intuition, because this is the crucible where ore is forged. When instinct fails, when imagination collapses, when metaphors betray you, that is when the scale of reality begins to sink in. The universe is not obliged to make sense to your senses. It is free to be stranger than comfort, freer than metaphor, vaster than imagination. And you, small, temporary, fragile, are asked to live inside that strangeness. It is humbling, it is disorienting, but it is also liberating. To see that intuition breaks is to see that the mind can grow beyond instinct. To know that the universe is not built for human comfort is to know that you can expand with it, stretching thought beyond the limits of sight. So you begin to train yourself to think differently, to hold images loosely, to use metaphors as stepping stones, not resting places. You picture the balloon, but remind yourself there is no air around it. You picture the bread, but remember there is no oven. You picture galaxies drifting, but remind yourself they are not moving through space. They are carried with it. Every image wrong yet useful, every metaphor false yet guiding. This is the discipline of thought in the face of the cosmic. And as you practice it, something softens. Expansion ceases to be absurd and becomes instead mysterious. Not unbelievable, but humbling. You no longer demand it feel natural. You allow it to be strange, and in that allowance, ore blooms. Because in the end, what matters is not that expansion matches your intuition. What matters is that it is true. That light, traveling for billions of years, carries the story in its stretched wavelengths. That galaxies scattered across the void recede in a pattern too precise to deny. That the universe itself, once thought eternal and still, is alive with restless growth. Your intuition is broken, yes, but in that breaking you glimpse something greater, a reality vaster than instinct, more patient than imagination, more real than comfort. And perhaps that is what it means to know the universe at all, to let your mind fracture and rebuild again and again, until it is wide enough to hold truths that once felt impossible. And now at last the fractures clear the way. You are ready to set intuition aside and ask the harder question: what is the actual evidence? What do we see, measure, chart and test that makes the case undeniable? What is the stack of proof that convinces beyond metaphor, beyond intuition, beyond doubt? You've wrestled with the strangeness. You've sat in the discomfort of a universe expanding in ways that intuition resists. And now the mind demands more. It is not enough to know that your instincts break. You want proof. You want the evidence that convinced scientists in the first place. So let us begin with light. Always it comes back to light. Because light is the messenger, the only thread between you and the vastness beyond. Every star, every galaxy, every flare of brilliance in the night sky hurls photons outward, racing across billions of years to find you. And within those photons is information, precise, measurable, undeniable. Imagine for a moment that you hold a prism in your hand, a simple piece of glass cut at angles. You let sunlight pass through and suddenly the white beam breaks into colors: red, orange, yellow, green, blue, violet, a rainbow caught in your grasp. This is the spectrum of light, the visible fraction of the electromagnetic wave, but beyond it lies more: infrared, ultraviolet, radio, gamma. The universe is a symphony of wavelengths, most of them invisible to your eyes but no less real. Now imagine turning that prism toward a star. Its light too breaks into a spectrum, but here something remarkable appears. Within the smooth rainbow are dark lines, thin gaps where certain colors vanish. These are absorption lines, fingerprints of the elements inside the star. Hydrogen leaves its marks in one pattern, helium in another. Carbon, oxygen, iron, each with its signature, a cosmic barcode etched by physics. This was the first great discovery of astrophysics, that the chemistry of the stars is the same as the chemistry of Earth. The same hydrogen burns in their hearts as fills your lungs. The same iron that composes your blood once fused in their cores. Light revealed this unity. The spectrum told the tale. But then came the deeper revelation. Those lines were not always where they should have been. Sometimes they were shifted, pushed slightly toward the blue or slightly toward the red. And that shift carried a meaning. You know the principle already from sound. A train whistle approaching screams at a higher pitch. As it passes and recedes, the sound drops lower. The waves compress when the source moves toward you, stretch when it moves away. This is the Doppler effect. It applies not only to sound but to light. A star rushing toward you will show its spectral lines shifted toward blue, its waves compressed. A star moving away shows its lines stretched toward red. The shift is small but measurable. A tiny skew in color, a subtle nudge in wavelength. And from that skew you can calculate velocity. You can know with certainty whether a star or galaxy is approaching or receding and how fast. When astronomers first began measuring these shifts in the light of galaxies, the results were bewildering. Some nearby galaxies showed blue shifts, yes, drawn toward us by local gravity. But most, the overwhelming majority, showed red, not faint, not occasional, but persistent, systematic. The further away a galaxy was, the stronger its redshift appeared. It was Edwin Hubble who turned this pattern into law. Working at Mount Wilson Observatory in the 1920s, he gathered measurements of dozens of galaxies, their distances estimated, their spectra captured. He plotted them on a graph, distance on one axis, velocity on the other. And what emerged was not chaos but a line, a steady upward slope. The farther away a galaxy, the faster it receded. This was not random motion, not galaxies wandering aimlessly in the void. It was systematic, universal, ordered. The very structure of the cosmos laid bare in a simple plot of dots and a rising line. This was Hubble's law: velocity is proportional to distance. Galaxies twice as far away recede twice as fast. The universe expands uniformly like a fabric stretching evenly in all directions. The power of this discovery cannot be overstated. For centuries, the debate had simmered. Is the universe static, eternal, unchanging, or does it evolve, grow, shift across time? With Hubble's data, the answer sharpened into clarity. Expansion was real. The galaxies themselves bore witness. The light itself testified. And here lies the elegance. The very strangeness that broke intuition became its own proof. Because if galaxies were merely flying outward through pre-existing space, the pattern would look different. Speeds would vary chaotically, tugged by local forces, scattered without order. Instead, the law was simple, linear, beautiful. Not motion through space, but the motion of space. Hubble himself was cautious. He did not leap to conclusions about beginnings or ends. He presented the data, the line, the law, but others quickly saw the implications. If everything is receding now, then once it was closer. Follow the slope backward and all galaxies converge, the distances shrink to zero, not at a point in space, but at a point in time. A beginning, a birth of the cosmos. This was shocking. It contradicted the long-cherished dream of a static universe. Even Einstein, who had built relativity, had resisted the idea of expansion. He had inserted a cosmological constant into his equations to hold the universe steady, unwilling to believe it could be otherwise. Hubble's data forced him to admit he had been wrong. Later, he would call it the greatest blunder of his career. The evidence was too strong. Redshift was not an illusion. The pattern was not a mistake. The expansion was written into the sky itself. And yet one measurement, one law is never enough. Science demands layers, confirmations, reinforcements. What if the redshift had another cause? What if light, traveling across cosmic distances, simply tired, lost energy, stretched its wavelengths not because of motion but because of some unknown property of space? The idea was raised, tired light, an elegant way to keep the universe static while explaining the data. But elegance is not enough. Hypotheses must meet the test of observation. And tired light, though clever, failed. If photons lost energy simply by traveling, they would blur as they went. Images of distant galaxies would smear, distort, lose clarity, but they do not. Across billions of light-years, galaxies remain sharp, crisp, distinct. Tired light could not explain this. Only motion could, only expansion. And so the evidence stacked. Redshift after redshift confirmed. More galaxies measured, more data points plotted. The line held, the law persisted. Each new telescope, each new instrument only reinforced the truth. The universe was expanding, and it had been doing so for billions of years. You sit with this, you imagine the graph, the line, the slope rising across the page. Dots scattered but obedient, each one a galaxy, each one a messenger. Together they tell a story older than Earth itself. A story not of stillness, but of restless growth. This is the first great layer of proof. The redshift, the law, the pattern that cannot be denied. But it is only the beginning. Other layers wait. The faint afterglow of the Big Bang, the distribution of galaxies across the sky, the way elements themselves formed in the fireball of creation. Each will build upon the last, stacking evidence until the case becomes unshakable. But here, with the first layer, you already sense the shift. The universe is no longer eternal and still. It is alive, expanding, unfolding. And you are not simply an observer. You are part of it, bound to galaxies carried outward on the same tide. The light told the secret, Hubble listened, and everything changed. The redshift spoke first, whispering of galaxies drifting away, of a universe stretching like fabric drawn tight. But redshift was only the beginning. A single thread of evidence is never enough. Science weaves its truths with many strands, each tested, each strengthened by the others. And if expansion is real, then its echo should be written into the universe itself, not only in galaxies, but in the very light that fills all of space. That echo exists, faint, invisible to the eye, but everywhere, the afterglow of a beginning, the memory of a cosmos once fire and flame, now cooled into a dim background hum, the cosmic microwave background. Imagine for a moment the universe in its earliest moments, not galaxies, not stars, not even atoms. Only a seething plasma of particles and light, tangled together, colliding in every instant. In such a world, light could not travel freely. Photons were trapped, scattered endlessly by electrons like sunlight in a fog too thick to see through. The universe was opaque, a glowing cloud of fire. But expansion changed this. As the universe stretched, it cooled. Slowly, the particles slowed, the collisions eased, until at last a moment came 380,000 years after the beginning when electrons and protons bound together into atoms. The fog cleared, the photons were freed, light could travel without being trapped, and that first free light has been traveling ever since, racing outward across billions of years, filling all of space. It is still here now. You are bathed in it as you sit. Every point in space hums with its faint glow, but time and expansion have stretched it. What was once a brilliant blaze has cooled to a whisper, its photons stretched into microwaves too long for your eyes to see. The cosmic microwave background, CMB, fills the sky, uniform, steady, ancient. This is the second great proof, because if the universe has been expanding for billions of years, it must once have been hotter, denser, more compressed. That heat cannot vanish. It must leave a trace, a fossil of fire. The CMB is that fossil, the proof that the cosmos was once a furnace and that expansion carried its glow into silence. The discovery came not from a grand telescope aimed with intent, but from accident. In 1965, two engineers, Arno Penzias and Robert Wilson, were working on a radio antenna in New Jersey. They were not hunting for the afterglow of the Big Bang. They were trying to build a communication system to tune their equipment with precision. But their antenna picked up a persistent hiss, a faint static that refused to vanish. At first, they suspected interference. Cars, city lights, radar from nearby airports. They checked everything. They even climbed into the antenna and cleaned away the nesting pigeons, believing the droppings might be the source of noise. But the hiss remained, steady, unrelenting, coming from every direction at once. And then came the realization: the noise was not interference, it was the universe itself. They had stumbled upon the background radiation, the cooled afterglow predicted by theory. Without knowing it, they had tuned their antenna to the echo of creation. What they had found was astonishing not only for its existence, but for its uniformity. The microwave background comes equally from all directions, no matter where you look. It does not matter whether you aim your antenna at the Milky Way or away from it. The glow is the same. It is a reminder that the early universe was remarkably smooth, almost featureless, filled with light evenly spread, but not perfectly smooth. Later instruments, satellites like COBE, WMAP and Planck, measured the CMB with exquisite precision, and they found faint ripples in the glow, tiny variations in temperature, only a few parts in 100,000. These ripples are the fingerprints of the first structures, the seeds of galaxies and clusters written into the universe when it was young. Expansion did not erase them. It preserved them, stretched them, froze them into the sky. To see the microwave background is to look back almost to the beginning. Not quite to the instant of creation, but close enough that the universe had not yet made stars, not yet built galaxies, not yet assembled planets. When you look at the CMB, you are staring into a world without suns, a cosmos that was still a glowing fog. Expansion carried that light forward until it cooled into invisibility, but technology lets us see it again, translate it into images, hear it as static in a radio. It is humbling to realize that every television set, every old radio tuned between stations, picks up traces of this signal. The static hiss you hear in the gaps is not only noise, it is a whisper of the cosmos, photons older than Earth itself brushing your ears. You cannot escape it. The afterglow of creation follows you everywhere. And this afterglow is not optional. It is not an extra detail added to the theory. It is a prediction. If the universe is expanding from a hot, dense past, then the CMB must exist. Without it, expansion would falter. With it, the case grows stronger. The redshift of galaxies told you the universe is growing. The microwave background tells you it once burned and that its fire cooled exactly as expansion demands. No tired light theory can explain this. No static universe can predict it. Only a cosmos that expands, that cools, that evolves can account for the CMB. It is the fossil of fire and it cannot be denied. Think of what this means for your place in time. The light that bathes you now began its journey when the universe was young, when no galaxies had formed, when no planets circled stars, when life was not yet even an idea. It has traveled for billions of years, stretched by the expansion of space, and now it touches you softly, invisibly. You carry the echo of creation on your skin. And it means something else too. Expansion is not only a concept measured in distant galaxies. It is an event you are living inside. The background radiation proves that the universe has a history, a childhood, a moment when it blazed with heat. You are alive in its middle age when the fire has cooled, when stars and galaxies bloom in the spaces expansion has opened. To live now is to be part of that ongoing story. So the evidence stacks. The redshift tells you galaxies recede. The CMB tells you the universe was once hot and dense, and that expansion has cooled it. Two witnesses, each independent, yet both pointing to the same truth. The cosmos grows and has grown for billions of years. And there are more voices still, more evidence waiting. The chemistry of the elements, the structure of the galaxies themselves, the rhythm of expansion measured again and again by new instruments. Each will add another strand, another reinforcement, another confirmation that the universe expands. But for now, stay with this one. Stay with the quiet hum of microwaves, the afterglow of fire. Imagine yourself listening to it, hearing the universe not in myth, but in static, in a faint hiss that comes from everywhere at once. That sound is the sound of proof. The galaxies spoke first. Their light shifted red, carrying the message of expansion. Then came the faint background glow, the afterglow of a fireball cooled by billions of years of stretching. Two witnesses already strong enough to bend the old universe into a new shape. But there is a third witness, quieter yet just as persuasive, the very matter you are made of. Because expansion does not only leave marks in light, it leaves marks in chemistry, in the recipe of elements that make up the cosmos: hydrogen, helium, lithium. These simple atoms are the fossils of the early universe, the residue of a time when all of reality was still a furnace. To understand this witness, you have to go back in imagination to the first minutes of existence. The Big Bang itself, whatever it was, however it began, is shrouded in mystery, but what followed it is more clear. The universe was unimaginably hot, unimaginably dense. Space seethed with particles colliding, fusing, annihilating. Energy and matter churned in a violent dance. And then, as expansion carried everything outward, the furnace cooled. At first, too hot for atoms, too hot for even nuclei to survive. Protons and neutrons slammed together only to break apart. But as seconds passed, the temperature dropped just enough for the first fragile unions. Protons and neutrons began to bind, forming deuterium, hydrogen with an extra neutron. That deuterium fused into helium and in tiny amounts lithium. This was the era of primordial nucleosynthesis, the universe itself acting as a nuclear reactor, forging the first elements in the crucible of its birth. It lasted only a few minutes, and when it ended, the recipe was set. 75% hydrogen, 25% helium, trace amounts of lithium, almost no heavier elements. The furnace cooled too quickly to make more. The rest would wait for stars billions of years later. So here is the third witness. If the universe began hot and dense, if it expanded and cooled in precisely the way the theory claims, then it must have left behind this elemental fingerprint. Not just any mix of hydrogen and helium, but exactly this ratio in every corner of the cosmos. The universe should be flooded with hydrogen and helium in predictable amounts, no matter where you look. And when astronomers looked, that is exactly what they found. Stars across the sky, galaxies near and far, gas clouds drifting in interstellar space all bore the same signature. 75% hydrogen, 25% helium. The numbers matched the predictions of nucleosynthesis perfectly. Expansion was written not only in light, but in the atoms themselves. This was not a trivial success. The ratios are too precise to be coincidence. Tweak the conditions of the early universe just slightly, make it expand too quickly or too slowly, too hot or too cool, and the chemistry breaks. Too much helium, too little hydrogen, no lithium at all. The actual mix you see today could not exist unless expansion unfolded exactly as theory describes. This then is the third strand of proof. Galaxies tell you expansion is happening now. The background tells you it has been cooling since the beginning. And the elements tell you that cooling had a fingerprint, frozen into the first minutes, still visible today. It is a strange thought, isn't it, that the very atoms in your body carry evidence of expansion. The hydrogen in your blood was born in that first fireball. The helium that balloons float on was forged not in stars but in the first 3 minutes of the cosmos. You are not only stardust, as Carl Sagan once said, you are Big Bang dust too, hydrogen atoms older than galaxies themselves. And this chemical witness is relentless. It speaks everywhere to anyone who listens. Across the sky, across billions of years, the ratios hold, the same fingerprint in every corner. Expansion left its mark in chemistry, and chemistry remembers. At this point, the case grows difficult to deny. Three independent lines of evidence, each strong on its own, all converging on the same story. Redshift, microwave background, primordial elements. The universe expands, and it has been expanding since it began. But science is cautious. Three witnesses are strong, but not enough to rest the case. More voices must join the chorus. Patterns in the distribution of galaxies, the ripples in the microwave background, the acceleration of expansion measured by distant supernovae, all of these will come. The evidence will stack higher, firmer, until the truth stands unshakable. Yet already you sense the weight of it. The galaxies are not random wanderers, they obey the law of expansion. The background is not accidental noise, it is the fossil of fire. The helium in your lungs is not coincidence. It is a signature from the first minutes of time. Three different paths, all converging, all pointing to the same truth. And in this convergence lies a deeper reflection. Expansion is not only a matter of astronomy, it is a matter of identity. The universe expands, and in that expansion it creates the conditions for you to exist. Without it, without the cooling, without the delicate balance of hydrogen and helium, there would be no stars, no planets, no life. Expansion is not just something that happens out there. It is the reason you are here. Think about that. If the universe had been static, eternal, unchanging, perhaps stars would never have ignited. If the ratios of elements had been different, chemistry might have failed. If the cooling had not been so precise, matter itself might have unraveled. And so the evidence is not abstract, it is personal. You are not only a witness to expansion, you are its child. This is what science at its best can do. It does not merely tell you how the universe works, it tells you how you belong to it. Redshift connects you to galaxies. The background connects you to the fireball. The elements connect you to the very birth of matter. You are woven into the fabric of expansion, inseparable from it. And yet there is still more to hear. The next witness speaks not of chemistry but of structure, of how galaxies themselves arrange across the sky, how their clustering reveals the rhythm of expansion frozen into space. Another layer of proof, another strand in the web. But for now, stay here with the elements. Take a breath. Feel the hydrogen that fills your lungs. Know that it has been waiting, unbroken, since the first minutes of time. Feel the trace helium drifting invisibly around you, forged before stars, before galaxies, before Earth. You are inhaling evidence. You are alive because of expansion. And the universe, still expanding, still cooling, carries you forward with it. The third witness has spoken, and the case grows strong. Galaxies gave their testimony. The background glow whispered its memory. The elements carried their fingerprint. Three witnesses already strong, already enough to tilt the mind into belief. But science asks for more. The universe, if it expands, should not only show itself in light and chemistry. It should show itself in structure, in the very way matter arranges across the cosmic stage. So let us turn the lens outward, not to a single galaxy or a faint glow, but to the grand tapestry of all galaxies, billions upon billions, scattered across space. Their distribution is not random. It carries a pattern, an echo of expansion frozen into its weave. Imagine tossing pebbles into a still pond. Each pebble sends ripples outward, circles expanding, overlapping, intersecting. The surface of the water becomes a map of echoes. The early universe was much like this pond, though the ripples were not water but sound, pressure waves moving through the hot plasma of particles and light. Expansion carried those ripples outward, froze them into the distribution of matter, and left them imprinted in the cosmic microwave background. Billions of years later, when galaxies formed, they fell into those same rippled patterns. Not perfectly, but enough to leave a statistical trace. When astronomers survey the cosmos on vast scales, they find galaxies are more likely to be separated by certain distances, echoes of those ancient sound waves. These are called baryon acoustic oscillations, the fossilized music of the early universe, expansion turned into rhythm. To measure this is no small task. It requires scanning millions of galaxies, mapping their positions with precision, tracing the clustering across the sky. But again and again the same ripple appears. The same scale repeats. It is the frozen memory of expansion, written not in light or elements, but in the very architecture of the cosmos. This alone would be another strong layer of proof, but there is more. Expansion does not merely shape where galaxies gather, it also dictates how fast that gathering changes, how structures grow over time. The pattern of galaxy clustering evolves in ways predicted only by an expanding universe. A static cosmos could never produce such structure. The map of the sky itself becomes evidence, another voice added to the chorus. And yet the story of evidence has another turn, one even stranger, one that deepened the mystery rather than resolved it. In the late 20th century, astronomers turned to a new kind of witness: distant supernovae, exploding stars used as cosmic lighthouses. Some supernovae have a remarkable property: they always explode with nearly the same brightness. By comparing how bright they appear from Earth, you can measure their distance. By measuring their redshift, you can know how fast they recede. Together, distance and speed paint a picture of expansion across time. The expectation was simple: if the universe expands, gravity should slow it down. The more mass in the cosmos, the stronger the pull, the more expansion should decelerate. The question was whether the universe had enough matter to eventually stop and collapse, or too little to halt, expanding forever but slower and slower. Either way, deceleration seemed inevitable. But when the data arrived, it told a different story. The supernovae were dimmer than expected. The galaxies were farther away than they should have been if expansion was slowing. The conclusion was shocking: expansion was not decelerating, it was accelerating. The universe was not merely stretching, it was stretching faster and faster, as if driven by some hidden energy, some invisible force. This discovery, made in the 1990s, reshaped cosmology again. Expansion was real, yes, but it was not slowing, it was racing. Something unknown, later called dark energy, was pushing space apart, dominating gravity itself. The cosmos was not only expanding, it was accelerating into an unknown future. This was not a small adjustment, it was a revolution. It meant that the universe was stranger than even Hubble had imagined. Expansion was not a gentle drift, it was a runaway tide. And the evidence came not from theory, but from observation, from light measured carefully across billions of years. So now the evidence stack stands tall. Redshifts, galaxies recede in proportion to distance. Cosmic microwave background, the fossil glow of a hot dense beginning. Primordial elements, chemistry frozen in the first minutes, matching predictions. Large-scale structure, ripples and clustering carved by expansion. Supernovae, proof that expansion not only happens but accelerates. Each layer independent, each layer converging, the case is unshakable. The universe expands. You sit with this, letting the weight of it settle. It is not speculation, it is not guesswork, it is not a story told in myth or metaphor. It is written in numbers, in light, in chemistry, in maps of galaxies, in the afterglow of fire. Expansion is as real as gravity, as certain as the orbit of Earth. And yet certainty does not erase wonder. If anything, it deepens it. Because knowing the universe expands only raises further questions. What is dark energy, the force behind acceleration? What lies in the past before the fireball? What lies in the future as expansion carries galaxies beyond reach into silence? The evidence does not close the story, it opens it. For now, though, you pause at the summit of proof. The stack is complete, the witnesses have spoken, the case has been made. The universe expands and the evidence is woven into every corner of reality. But belief is not the end of the journey. Next comes the harder work, confronting the counter cases, the alternative visions, the questions that still linger at the edges of knowledge. Because science is not only about proof, it is about doubt, about testing every possibility until only the strongest remains. And so the journey will turn again into the counter cases, into the challenges that expansion had to survive, into the voices that once resisted, and the ways they were answered. The universe is expanding, that much is certain. But what does it mean to live inside an expanding universe? What does it mean for beginnings, for endings, for meaning itself? The evidence has spoken. Layer upon layer, it has built a case too strong to ignore. Redshifts, background radiation, primordial elements, cosmic structure, supernovae, all pointing in one direction, all whispering the same truth: the universe expands. And yet truth is never embraced so easily. The history of science is not a straight road from ignorance to knowledge. It is a twisting path full of doubt, resistance, and challenge. Every great discovery invites its countercase, its opposition, its refusal to be believed. Expansion was no different. Because even as the data stacked, many voices asked, "What if we are wrong?" The first resistance came not from ignorance, but from the greatest minds of the age. Albert Einstein himself, before Hubble's law, resisted the idea of a dynamic universe. His own equations of general relativity, written in 1915, suggested that the cosmos could not remain static. Gravity would pull it together, collapse it inward, unless, that is, some hidden force held it open. And because Einstein could not imagine an expanding universe, he inserted such a force into his math, the cosmological constant, a balancing term to keep the cosmos still. He thought he was preserving reason. He thought he was protecting against absurdity. Only later, after Hubble's discoveries, would he call it his greatest blunder. But Einstein was not alone in his resistance. Many astronomers and physicists of the early 20th century recoiled at the thought of a universe with a beginning. A cosmos that expanded implied a cosmos that once was smaller, denser, younger. Trace the line backward and you arrive at something uncomfortably close to creation, a moment of origin. To some, this felt too theological, too mythic, too unscientific. They wanted eternity, not birth, permanence, not story. And so alternatives were built. The most famous was the steady-state model, proposed in the mid-20th century by Hermann Bondi, Thomas Gold, and Fred Hoyle. They accepted that galaxies appeared to recede, yes, but they refused to believe the universe had a beginning. Instead, they argued as galaxies drifted apart, new matter was constantly created to fill the gaps. Expansion, yes, but eternal, steady, unchanging in its overall character. No beginning, no end. The steady state was elegant in its way. It explained why the cosmos looked the same in every direction, why no edge or center could be seen. It offered the comfort of eternity, the reassurance of a universe without birth or death, and for a time it held strong. Fred Hoyle, in fact, coined the term Big Bang as a dismissive nickname, mocking the idea of a universe exploding into being. To him, steady state was the rational alternative, the bulwark against myth disguised as science. But there were other counter cases, too. Some questioned the redshift itself. Perhaps light, traveling across billions of years, lost energy in ways not yet understood. Perhaps photons stretched not because galaxies moved, but because space itself tired them. This tired light hypothesis offered an elegant escape from expansion, preserving a static cosmos. Others wondered if the universe was not expanding at all, but curved in ways that tricked our instruments. Perhaps relativity bent light so profoundly that galaxies only appeared to recede. Perhaps the redshifts were illusions, mirages conjured by warped space-time. Even the microwave background, when first discovered, faced resistance. Could it not be local noise? Emission from dust, from stars, from within our own galaxy? Was it truly universal or just another signal misinterpreted? Science thrives on such resistance. Each objection is a test, a sharpening of truth against doubt. And in the decades that followed, each countercase would be examined, challenged, and eventually undone. But for a moment, pause in that time before certainty. Imagine yourself as an astronomer in the 1940s, 1950s. The redshift law is known, but its meaning is debated. The microwave background has not yet been discovered. The primordial elements are not yet measured. All you have is a pattern in the galaxies, a line on Hubble's graph. Does that alone prove the universe expands, or could it be something else, something subtler, stranger? You would feel the pull of doubt. You would hear Hoyle's steady-state argument and wonder, perhaps he is right. Perhaps the cosmos has always existed and always will. Perhaps expansion is just one feature of an eternal universe, not evidence of a beginning. You would hear the tired light hypothesis and consider, photons crossing billions of light years, could they not blade energy into the void? Could the redshift be weariness, not recession? You would even look at Einstein's original instinct and sympathize. A dynamic universe feels absurd. Expansion feels unnatural. Surely the cosmos must be steady, stable, balanced. Surely eternity is more reasonable than birth. This is the counter case. The universe cannot expand because expansion breaks intuition. The universe cannot expand because a beginning feels like myth. The universe cannot expand because alternatives exist, tidy, clever, comforting. And so the debate raged, conferences filled with argument, papers stacked with counter-proposals, observations challenged, reinterpreted, doubted, science at its sharpest, wrestling not only with data but with the discomfort of change. In a way you can sympathize. Even now, knowing what you know, the thought of a universe that expands into nothing, that accelerates into silence, still unsettles. Imagine how much harder it must have been then when the evidence was fewer, the theories more fragile. Resistance was not foolish, it was necessary. It forced the truth to be tested again and again until it could not be shaken. But for the moment, hold yourself in that space of doubt. Let yourself feel the allure of the counter cases, the elegance of steady state, the simplicity of tired light, the comfort of eternity. Imagine the relief of believing in a universe without origin, without an end, without the unsettling strangeness of expansion. And yet, even as you let yourself feel that relief, you know the tide will turn because evidence is patient, relentless. The microwave background will be discovered, the primordial elements will be measured, the supernovae will reveal acceleration, and one by one the counter cases will fall. But that is later. For now you are in the middle of the storm. Certainty is not yet won. The universe is expanding, perhaps or perhaps not. The arguments rage, the questions deepen, the truth waits. And in that waiting, in that doubt, you glimpse the fragility of knowledge, the struggle it takes to accept the strange. Science is not a story of answers handed down. It is a story of battles fought in the mind, of resistance broken by patient evidence, of counter cases weighed and found wanting. The universe expands, but before that truth could be embraced, it had to be doubted. And those doubts, those alternatives, deserve to be heard. The universe expands, the evidence insists, and yet not everyone was ready to follow. The counter cases had their day and they must be heard, because doubt is not weakness, doubt is strength. It is the crucible that tempers truth. So imagine yourself, mid-20th century, standing in a room of astronomers, chalk dust in the air, equations smeared across blackboards. The evidence of redshift is clear, but still hands are raised, voices argue, countervisions are offered. Each one clever, each one seductive. The first counter case is the simplest, tired light. The idea seems almost elegant in its economy. Perhaps light itself changes as it travels. Perhaps photons, crossing billions of light years, lose energy, stretch their wavelengths, redden not because galaxies recede, but because space wears them down. Imagine a runner slowing after endless miles, a violin string slackening after hours of play. Why not light too? If tired light were true, the universe could remain static. No expansion needed. No beginning, no fireball, no unsettling strangeness. Just a cosmos at rest and light itself to blame for the illusion of motion. For a moment the theory had charm. It explained redshift without tearing intuition. It offered eternity instead of birth, but the charm faded when tested. If photons lost energy by scattering, by interaction, then images of distant galaxies should blur. Like headlights in fog, the light should smear, details washed away. Yet the galaxies, even the faintest, remained sharp. Tired light could not explain that. Worse still, tired light predicted no change in time. But when astronomers looked at distant supernovae, they saw their explosions stretch, slow down, their light curves elongated by expansion. The clock of the cosmos ticked differently across distance. Tired light could not account for this. The photons did not tire. They carried time itself, stretched by expansion. So tired light, once elegant, fell away. The data broke it. The illusion of simplicity could not withstand the detail of observation. The second counter case was grander, more ambitious, the steady-state model. Proposed in the late 1940s, it accepted expansion but refused a beginning. Bondi, Gold, and Hoyle argued, yes, galaxies move apart, but the universe does not thin out. New matter is created continuously, atom by atom, filling the gaps, keeping density constant. Expansion, yes, but eternal, steady, unchanging in its overall appearance. It was bold, it was radical, and it carried a seductive promise. No Big Bang, no moment of creation, no uncomfortable origin. The cosmos had always existed, would always exist, stretching but never changing in essence. Fred Hoyle championed it with vigor, dismissing the rival Big Bang theory with a mocking phrase on a radio broadcast. The term stuck long after the mockery faded. For years, steady state competed with Big Bang as a serious rival. Both explained Hubble's law. Both described galaxies receding. Both accounted for the sky we saw, which was true. Only new evidence could decide. And the evidence came. First in 1965 with the discovery of the cosmic microwave background. A steady-state universe could not produce such an afterglow. There was no hot, dense past to cool, no universal fireball to leave behind a fossil. The background radiation was the death blow, the proof that the universe had once burned. Then came the counts of galaxies at different distances. In a steady-state cosmos, the universe should look statistically the same at all times, but it did not. Farther away, looking deeper into the past, the universe looked different. Galaxies younger, more chaotic, more irregular. Evidence of evolution, not eternal sameness. Another crack in the steady state. By the 1970s, the model was collapsing. By the 1990s, it was gone, a relic of resistance. And yet for decades, it had been a serious alternative. For decades, it had been believed. Such is the strength of doubt. The third countercase was subtler, less of a theory than a suspicion. Relativistic illusion. Einstein's relativity bends light, warps geometry, distorts perception. Could it be that the redshifts were not expansion but trickery? Perhaps spacetime curved in ways we misunderstood. Perhaps galaxies only appeared to flee, their light bent, their positions distorted. It was not impossible. Relativity is subtle, its mathematics twisting intuition into knots. For a while, some argued that expansion was an illusion of geometry, not reality. But again, the evidence did not agree. The linear law of Hubble was too precise, too systematic to be explained by curvature alone. The microwave background, the primordial elements, the supernovae, all reinforced expansion in ways relativity alone could not mimic. Geometry could bend light, yes, but it could not create fossils of fire, it could not write helium into the cosmos. It could not stretch the ticking of distant clocks. And so the suspicion, though natural, faded. Expansion was not illusion, it was fact. There were other minor counter cases too. Local motions misinterpreted, dust scattering light, unknown forces tampering with photons, each one proposed, tested, and undone. The pattern repeated, clever ideas crumbling under the weight of evidence. You might wonder why linger on these failures. Why tell the story of what was wrong? Because the wrong paths matter. They reveal the terrain of truth by contrast. They show that expansion was not accepted lightly, not swallowed without question. It had to fight. It had to survive doubt. And in surviving, it proved itself stronger. Science is not a tale of smooth ascent. It is a tale of struggle. For every truth, a dozen alternatives rise. For every discovery, resistance pushes back. And only through that friction does certainty emerge. The universe expands, but that truth was forged in fire, tested against tired light, against steady state, against illusion, against doubt. It survived not by rhetoric but by evidence. Again and again, the data broke the alternatives until only expansion remained. And perhaps there is a lesson here beyond science. Doubt is not the enemy of truth. Doubt is its companion. It is the force that makes truth prove itself. Without tired light, expansion would not have sharpened its edge. Without steady state, the Big Bang would not have gathered its strength. Without illusion, the evidence would not have been examined so closely. Truth is born not from comfort, but from conflict. And so, when you look at the expanding universe now, you see not only galaxies drifting, or background glowing, or helium forged. You see a victory of patience over doubt, of evidence over comfort, of reality over intuition. But the counter cases do not vanish entirely. Their spirit lingers. Even today some ask, what if? What if we have misread the data? What if another explanation waits? The questions are never fully silenced. They cannot be, and perhaps they should not, for doubt is what keeps science alive. Still, the balance has tipped. The counter cases have had their day, they made their stand, they fell, expansion endures. But the story is not yet over. For beyond the evidence, beyond the counter cases, lies the synthesis, the weaving of truth into meaning, the deeper reflections on what expansion tells us about beginnings, about endings, about existence itself. That is where the path will turn. But before we synthesize, the counter cases still have more to say. Their fall deserves to be seen in detail, their weight felt, their collapse understood. Only then can the synthesis ring true. And so, next, we will linger a little longer in their company. The counter cases had their day. Tired light whispered its simplicity. Steady state promised eternity. Relativistic illusion hinted at trickery. For a moment, each seemed possible. Each drew followers, built arguments, held the stage. But the universe is not persuaded by elegance. It is persuaded only by truth, and truth speaks in evidence. So let us watch the counter cases fall, one by one. First, tired light. At first glance, it felt like the cleverest escape. Light is all we see of the distant universe. If light itself changed along the way, then the redshifts need not mean expansion at all. Photons could grow weary, stretching into red not because galaxies fled, but because the journey drained them. The cosmos could remain eternal, still at rest. But when tested, the charm unraveled. If light lost energy by scattering, then the images of distant galaxies should blur. Each collision, each scattering would smear the signal like words blurred by smudged ink. Yet even across billions of light years, galaxies appear sharp. Their spirals wind with clarity, their edges defined. No fog blurs their shapes. Tired light cannot explain this. Worse still, tired light predicts no change in time. It stretches wavelengths, yes, but it leaves the rhythm of events untouched. Expansion does not. Expansion slows the ticking of distant clocks. Light curves from supernovae stretch, explosions appear to unfold in slow motion, precisely as predicted by expansion. Tired light cannot reproduce this. So the theory fell, elegant in imagination but brittle in evidence. The photons do not tire, the universe expands. Next, the steady state, more ambitious, more seductive. Bondi Gold and Hoyle crafted it with confidence. Galaxies drift apart, yes, but new matter is born in the gaps, keeping density constant, keeping the universe eternal. Expansion without beginning, motion without creation. For a time, the idea held sway. Observations of galaxies could fit both Big Bang and steady state. The sky looked uniform as both predicted. For a decade, two universes competed, one with a birth, one without. But then came 1965. Penzias and Wilson, their antenna tuned to the sky, found the hiss that would not vanish. The cosmic microwave background, the fossil glow of a hot, dense beginning. The steady state could not predict this. A universe eternal and unchanging could not carry such an afterglow. There was no furnace to cool, no fog to clear, no light to release. The microwave background was the death knell. Hoyle and his allies tried to explain it away: dust, local emission, errors in measurement. But as instruments improved, the glow only grew clearer. Satellites mapped it in detail, its spectrum a perfect blackbody curve, the exact signature of a cooled fireball. The steady state collapsed under the weight of fire. And as if that were not enough, galaxy counts delivered the final blow. In a steady-state cosmos, the universe should look statistically the same at all distances, but it did not. Farther away, deeper in time, the galaxies were younger, more chaotic, more irregular. The universe evolved, it changed, it grew, steady state could not hold. So the theory fell, bold in ambition but undone by fossils of fire and maps of galaxies. The universe is not eternal in form. It has a history, a childhood, a beginning. Then came the subtler suspicion, relativistic illusion. Relativity bends light, warps space, twists geometry into shapes the mind struggles to follow. Could it be that the redshifts were illusions, artifacts of curvature, distortions of perspective? Again, the suspicion had merit. Relativity does strange things. It warps time, slows clocks, bends paths of light. Perhaps expansion was not real, but geometry playing tricks. But again, evidence spoke louder. The redshift law was too precise, too linear, too systematic. Curvature alone could not produce such a pattern. And beyond redshifts, other evidence mounted. The microwave background, the primordial elements, the supernovae. Geometry alone could not explain them. Illusion could not account for fossils of fire or helium forged in the first minutes, or time-stretched explosions billions of years away. So the suspicion faded. Relativity was not the enemy of expansion. It was its framework, its foundation. Expansion was not illusion, it was reality. Each countercase tested fell, each elegant escape undone by detail. The tired light blurred where galaxies remained sharp. The steady state broke where the microwave background glowed. Relativistic illusion crumbled where supernovae stretched time itself. The collapse of these alternatives was not only scientific, it was emotional, cultural. To abandon steady state was to abandon eternity. To accept expansion was to accept a beginning, a story, a universe that had not always been. For some, this was uncomfortable, even unbearable. Hoyle resisted to his last, never fully conceding, crafting ever more elaborate alternatives to preserve his eternal cosmos. But evidence is patient, it waits, it does not bend to comfort. And so expansion survived, not because it was the easiest idea, not because it fit intuition, but because it fit reality, because it explained not only redshifts but microwave background, helium, galaxy clustering, supernovae, acceleration. It explained more than any rival could. Science advances this way not by declaring truths but by eliminating alternatives. What remains is what survives the fire of doubt. Expansion survived, it remains. And so, as you sit with the story, you see not only a universe that grows, but a process of thought that grows with it. A process that welcomes doubt, that builds counter cases, that tests them until they fall. This is the beauty of science. It does not fear being wrong, it expects it. It requires it. Truth is not the first idea, but the last one standing. Now expansion stands alone, unbroken, but the fall of its rivals leaves a haunting echo. For if even steady state, once so convincing, could collapse, what of expansion itself? Could some future discovery overturn it too? Could another model arise, stronger still, to explain everything expansion explains and more? It is possible, it is always possible. Science does not deal in absolutes. Every truth is provisional, waiting for the next test. Expansion has survived a century of challenges, but the future remains open, uncertain, alive with the possibility of surprise. Still, for now, the case is clear. The counter cases fell, expansion endures. And in their falling, you learn something vital. The universe is not what feels natural. It is what is true. Eternity feels natural. Stillness feels natural. A flat, eternal sky feels natural. But truth is not beholden to feeling. Truth is beholden to evidence. The universe expands, not because it feels right, but because it is right. Next, the journey will linger one last time in the counter case. The emotional resistance, the human reluctance to accept a beginning, the philosophical weight of an expanding cosmos. Because the fall of the counter cases was not only scientific, it was existential. The counter cases have fallen, one by one, undone by the weight of evidence. Tired light blurred where galaxies stayed sharp. Steady state shattered against the glow of the cosmic microwave background. Relativistic illusion dissolved when time itself stretched in supernovae. Each rival theory was tested, measured, and broken. But resistance does not live only in equations. It lives in hearts and minds. The last counter case is not scientific at all. It is emotional, it is philosophical, it is human. Because to accept an expanding universe is to accept something unsettling. It is to accept that the cosmos has a history and by implication a beginning. That there was a time when there was no Milky Way, no Earth, no you. That there was a time when space itself was compacted into a state so dense and hot that no familiar image can hold it. That there was a time before stars, before light traveled freely, before even atoms could exist. For centuries, humanity leaned on the comfort of eternity. The sky seemed eternal, the stars unchanging, the universe a stage without beginning or end. Philosophers found security in that stillness. A cosmos without birth is a cosmos without death. It reassures like a parent's embrace, endless, constant, unbroken. But expansion denies that comfort. Expansion insists that the universe is not eternal in form. It insists that the stars had a first light, that galaxies had a first swirl, that matter itself had a first spark. It insists that everything you know is temporary, a chapter in a larger story, and that implication is not easy to accept. Fred Hoyle, the most famous defender of steady state, was not only fighting for an equation, he was fighting for permanence. He saw the Big Bang as too close to theology, too close to myth. A creation event sounded unscientific to him, too much like Genesis cloaked in physics. For him, eternal steady state felt more rational, more honest. He resisted not only because of data, but because of meaning. And Hoyle was not alone. Many scientists, philosophers, and ordinary people shared that instinct. A universe with no beginning is simpler to imagine, easier to bear. A universe with a beginning raises questions that science alone struggles to answer. If there was a moment of creation, what came before? If time itself began, how can there be a before at all? If the cosmos had an origin, why did it happen? Why anything instead of nothing? These are not small questions. They are questions that stretch beyond astronomy into philosophy, into faith, into the marrow of existence. To accept expansion is to step into those questions unshielded. No wonder resistance ran deep. And then there is the other side of resistance, the future. If the universe is expanding, if galaxies are receding, if space itself is stretching, then where does it end? What happens when expansion has carried everything too far? Look forward billions of years and you see the implications. Seas slipping away beyond the horizon, their light stretched until it vanishes. The night sky growing emptier, lonelier. A cosmos where stars burn out, where light dims, where expansion leaves nothing but cold, thin silence. This too unsettles. Eternity, even if cold, offers permanence. Expansion offers impermanence. A cosmos with a beginning is also a cosmos with an end, and that end is not comforting. So you can understand the resistance. It is not only a matter of scientific pride or intellectual rivalry. It is a matter of human longing. Expansion asks you to give up eternity. Expansion asks you to live with impermanence. Expansion asks you to stare at a cosmos that is not fixed, not permanent, not secure, but restless, fleeting, and finite in its forms. And yet in that impermanence there is also beauty. A still universe is lifeless. No change, no growth, no story. Expansion makes stars possible, galaxies possible, life possible. The very instability that unnerves you is the source of your existence. Without expansion, you would not be here to resist it. Perhaps this is the paradox at the heart of the counter case. Resistance is born from fear of impermanence, but impermanence is the condition of life. A static universe offers comfort, but it also offers sterility. An expanding universe offers discomfort, but also creativity. To live inside expansion is to live inside story. A story with a beginning, a middle, and perhaps an end. And maybe that is why the resistance feels so personal. Because if the universe has a story, then so do you. And like the universe, you too are temporary. Hoyle resisted expansion until his death. Even as the evidence piled higher, he held to steady state, revising, reimagining, never conceding. Perhaps he could not bear the alternative. Perhaps he could not give up eternity. Or perhaps he believed doubt itself was noble, that truth should never be surrendered too easily. In that, perhaps he was right. His resistance sharpened the truth, forced it to prove itself, made it stronger. But resistance cannot erase reality. The universe expands, and with that acceptance comes a choice. You can mourn the loss of eternity, or you can marvel at the gift of impermanence. You can fear the beginning and end, or you can stand in awe at the middle. You can resist, or you can embrace. This, then, is the last counter case, not a theory of physics, but a condition of the heart. The longing for stillness, the refusal of impermanence, the fear of beginnings and endings. It is not wrong, it is human, but it cannot change the truth. The truth is this: the universe expands. It began in fire, it will end in silence, and between those two it blooms with galaxies, stars, planets, and life. Between those two it blooms with you. The scientific counter cases fell to evidence. The human counter case remains softer, subtler, harder to silence. But perhaps it should not be silenced. Perhaps it should be carried, acknowledged, honored. For it reminds you that science is not only about equations, it is about existence, and existence is not always easy to face. Now the counter cases are complete. The rivals have been tested, the doubts have been weighed, the resistance has been felt. What remains is expansion, standing unbroken, stronger for having been challenged. The time has come to turn again, to move from opposition to integration, from doubt to synthesis. to weave together the science and the meaning, the evidence and the wonder into a story you can carry. Because expansion is not only a fact, it is a lens, a perspective, a way of seeing the universe and yourself within it. The debates have ended. The counter cases have been tested, challenged, and undone. Expansion remains not as speculation but as certainty, sharpened by doubt, proven by evidence, unbroken by resistance. Now comes the work of weaving, the work of drawing the threads together, of letting the science deepen into meaning. Because expansion is not only a fact about galaxies, it is a truth about existence itself. So pause here, take a breath, let the evidence settle. Redshifts, microwave glow, primordial chemistry, galaxy clustering, supernovae. You have followed them across billions of years, across rival theories and fallen alternatives. Now let them merge, let them form a single vision. The universe expands. It has always expanded since its first instant. It expands not into anything but within itself, everywhere at once. Galaxies recede, carried by the stretching of space. Light stretches with them, cooled into whispers. The chemistry of your body was forged in the first minutes of that expansion. The structure of the cosmos is shaped by ripples frozen into place. The acceleration of expansion carries the story forward faster than before. This is the scientific synthesis. A universe that grows, a universe with a history, a universe with a future. But there is another synthesis, quieter, more personal. Expansion is not only about galaxies far away. It is about the way you see time, about the way you see yourself. Because to live in an expanding universe is to live in impermanence. Nothing is fixed, nothing is eternal, everything changes, the galaxies drift, the stars ignite and die, even atoms decay eventually. Expansion is the reminder that nothing holds still, and yet impermanence is not emptiness. Impermanence is the condition of story. If the universe had not expanded, if it had remained static and eternal, nothing would exist. No stars, no galaxies, no life. Change is what allows creation. Expansion is what allows existence. Think of it this way: a still pond may be calm, but it is lifeless. A pond with ripples, with currents, with movement, this is where life stirs. The universe is like that. Expansion is its ripple, its current, its movement. Without it, there is no story to tell. You too are impermanent. You too are a story unfolding in time. Your atoms were forged in stars, your hydrogen born in the Big Bang, your life a brief chapter in a cosmic book. Expansion is not separate from you. It is your context, your origin, your condition. You expand with the universe, carried forward with everything else. This is the deeper synthesis. Science and existence are not separate. They are one. To understand expansion is not only to know how galaxies move, it is to know what it means to exist in a universe that moves. And once you accept this, new reflections open. For instance, the beginning. Expansion tells you there was one, a moment when everything was compressed, when the universe was smaller, hotter, denser. Call it the Big Bang, though the name is misleading. It was not an explosion into space, but an expansion of space itself. That beginning is not myth, it is physics, and yet it feels mythic all the same. To say the universe had a birth is to step into a question larger than science. Why? Why this moment? Why something rather than nothing? Why a universe at all? Science cannot answer that fully. It can trace the expansion back. It can describe the first seconds, the first minutes, the first fireball of nucleosynthesis. But before that, before time itself, the questions drift into silence. And perhaps that silence is part of the synthesis too. To know that you cannot know everything. To accept that some questions will remain open, not because science fails, but because reality itself is deeper than answers. Then there is the other end of the story, the future. Expansion implies it. If the universe expands, it evolves. If it evolves, it has a destiny. Will it expand forever, thinning into silence? Will dark energy drive it into acceleration so fast that galaxies vanish beyond reach, stars fade, matter itself dissolves? Or will something else intervene, something not yet known, a shift in the balance of forces? You do not know, no one knows. And that too is part of the synthesis, knowledge mixed with mystery, certainty braided with uncertainty. You know the universe expands, you do not know where it leads. Both truths stand side by side. And perhaps that is the most important weaving, the union of certainty and wonder. Science gives you evidence, proof, clarity. but it also gives you awe, humility, the recognition of limits. To know the universe expands is to know both more and less. More about how galaxies move, less about why there is a universe at all. This, then, is the gift of synthesis. You began with a question: how do we know the universe is expanding? You followed the evidence, tested the counter cases, watched them fall. You accepted the truth. And now, in synthesis, you see that the truth is more than data. It is meaning. The universe expands, and that expansion is not separate from you. It is the condition of your being. You are woven into it. You are part of it. Every breath, every thought, every moment is carried on the tide of expansion. Sit with that, let it sink in. Let it soften your sense of self. You are not small against the cosmos. You are the cosmos experiencing itself in a brief, conscious flicker. You are expansion, aware of itself. That thought may be overwhelming, but it may also be calming. Because if expansion teaches anything, it teaches that impermanence is not failure. Impermanence is the way of things. Stars die, galaxies drift, universes evolve. And in that evolution lies beauty, existence itself. So when you wonder how we know the universe expands, you are also wondering how you know yourself. The same light, the same elements, the same forces that prove expansion also prove your belonging. You are not separate. You are not an observer standing outside. You are inside, carried along, made of the same fabric that stretches. This is the synthesis: science and self, evidence and meaning, fact and wonder. And from here, the journey continues deeper still. Because once you see yourself inside expansion, once you feel the unity of science and existence, you begin to ask, what does this say about beginnings, about endings, about the nature of time itself? Those questions wait just ahead. The universe expands, that much is certain. The science is clear, the evidence overwhelming, but certainty is only the surface. Beneath it lies something stranger, harder to hold: what expansion means for time. Because expansion is not just about galaxies drifting away. It is about history itself. It is about the shape of time. It is about the fact that the universe has a story with a first chapter and chapters yet to come. For most of human history, eternity was the default assumption. The sky was fixed, the stars eternal. Civilizations rose and fell, but the heavens endured. Time was cyclical, repeating with seasons, or endless, stretching without beginning or end. Eternity comforted. It required no questions about origins, no fears about endings. It was stable, dependable, unmoved. But expansion shattered eternity. Expansion tells you the universe has a past, a present, and a future. Expansion tells you time is not infinite in both directions. It tells you there was a moment when everything began. Think of that for a moment. A beginning, not only of stars and galaxies, but of space itself. Not only of space, but of time itself. A moment when there was no before, because before had not yet been invented. Expansion is not simply about growth, it is about birth. The thought is dizzying, it bends the mind, cracks intuition. You cannot picture it, every image cheats. You imagine an explosion, matter flying outward into emptiness. But that is wrong. The Big Bang was not an explosion into space. It was the expansion of space itself, no outside, no beyond. Only the inside swelling. You cannot picture it, and yet you know it is true. The evidence insists. The redshifts, the microwave glow, the helium in your blood, they all point back to that moment, that first chapter, that beginning. And then the question follows: what came before? The human mind cannot help but ask. What lay before the beginning? What caused it? What existed when nothing yet existed? Science answers carefully. In one sense, nothing came before. Time itself began with the Big Bang. Asking what came before is like asking what is north of the North Pole. The question collapses under its own weight. There is no before because before requires time, and time began then. But the mind resists that answer. It cannot accept it. It insists on a before. It insists on causality, on sequence, on origin. And so theories emerge. Quantum fluctuations, cyclic universes, multiverses bubbling, each with its own birth. Science stretches imagination, trying to give the question form. But even if answers remain elusive, the synthesis is clear. Expansion forces you to confront beginnings. It forces you to accept that the universe has a story and you live in the middle of it. And if beginnings matter, so do endings. Expansion implies a future, and the future is not comforting. Look far enough ahead and galaxies slip away, carried faster and faster by accelerating space. One by one they vanish beyond the horizon, their light stretched into invisibility. The night sky grows emptier, stars burn out, black holes evaporate, matter thins, energy spreads, expansion wins, and the universe cools into silence. This is the heat death, the long, slow fade into nothing, the final chapter of expansion. It is not the only possibility. Perhaps dark energy changes, perhaps gravity claws back, perhaps cycles emerge. But with what we know now, the story points towards silence. Expansion is not only the origin of existence, it is the condition of its end. This too is part of the synthesis. To live in an expanding universe is to live between fire and silence, between a beginning and an ending. You might feel despair at this thought. To know the cosmos will one day fade, to know even galaxies are temporary, to know even light itself is not forever. But there is another way to see it. Impermanence is not failure, it is the condition of beauty. A universe without change would be sterile. A universe without endings would be lifeless. Expansion is the reason stars exist at all. Expansion is the reason life exists at all. Expansion is the reason you exist at all. To be temporary is not to be meaningless. It is to be part of a story, and stories are beautiful because they end. Think of a piece of music. Its notes fade as they are played, never to return. Its beauty lies in its passing. A song that never ended would lose its meaning. The universe is like that. Expansion is its rhythm. Beginning, middle, end, fire, bloom, silence. The beauty lies in its impermanence. So the synthesis is this: expansion is not just about galaxies, it is about existence itself. It is about beginnings and endings, creation and impermanence, time and story. Science proves it, philosophy feels it. Together they make it real. And within that synthesis you find yourself again, because your life too is an expansion. You began, you will end. Between those two you bloom. Like the universe, you are temporary. Like the universe, you are beautiful in your impermanence. The hydrogen in your body was born in the first minutes of expansion. The carbon and oxygen in your cells were forged in stars lit by expansion. Your life is not separate from this story. It is this story in miniature. You are the universe, briefly aware of itself. This thought may feel overwhelming, but it may also feel calming. Expansion is not your enemy. It is your condition. You are not outside the cosmos, watching it grow. You are inside, carried with it, woven into it. And so the synthesis grows deeper. Expansion is fact, expansion is story, expansion is self. What began as a question, how do we know the universe is expanding, has become something more. You know because the evidence speaks, because the counter cases have fallen, because the synthesis weaves truth into meaning. But you also know that knowing is not the end. Expansion carries you into mystery, into questions that cannot be answered, into horizons beyond reach. Expansion carries you into awe. And awe may be the truest synthesis of all, the union of knowledge and wonder, the recognition that the more you know, the more there is to marvel at. So sit with awe for a moment. Feel the galaxies drifting, the light stretching, the atoms in your body humming with ancient fire. Feel yourself carried outward with the tide of space, woven into a story larger than thought. This is the synthesis. This is expansion, not only of the universe, but of the mind. And from here, the journey will turn again, deeper still into meaning, into reflection, into what it means to live in a universe that expands not only in space, but in imagination. The universe expands. You know this now not only as a fact, but as a story of beginnings, middles, and endings, a story of impermanence, of change, of becoming. But what does it mean to live inside such a universe? What does it mean for you, a conscious flicker on a small planet circling a small star, to exist in a cosmos that stretches endlessly? It means, first, humility. Stand outside on a clear night, far from city lights, and look upward. The stars scatter across the darkness, countless, ancient. Beyond them lie galaxies, millions of them, each holding billions of stars. Beyond those, more galaxies, stretching into distances you cannot grasp. Expansion means that even as you look, those galaxies are drifting farther, carried away on the tide of space. Most are already unreachable, their light destined never to reach you. The scale overwhelms, the distances crush intuition. You are small, impossibly small, a breath in the life of the cosmos, a single note in a symphony billions of years long. Expansion makes this clear. It reminds you that the universe is not built for human comfort. It does not orbit around you. It does not bend to your needs. You are not the center. There is no center. There is only the vastness, everywhere expanding, everywhere receding. But humility is not humiliation. To be small is not to be meaningless. You are small, yes, but you are also aware. You are the cosmos knowing itself. The galaxies drift, but you can measure them. The background glows, but you can detect it. The elements whisper their ratios, and you can decode them. Expansion does not erase your significance, it reshapes it. You are significant not because you are central, but because you are part of the whole. This leads to the second meaning, belonging. Expansion can feel alienating at first. The idea that galaxies are fleeing, that the universe grows cold and empty, that even light itself will one day fade, it can leave you feeling adrift, alone. But look closer and the opposite is true. Expansion ties you to everything. The hydrogen in your veins was born in the first minutes after the Big Bang. The carbon in your cells was forged in stars, themselves lit by the spaces expansion created. The oxygen you breathe exists because expansion allowed galaxies to form, stars to ignite, elements to fuse. Every breath you take is a testimony to expansion. You are not separate from the universe. You are its continuation. Belonging is not found in being at the center. Belonging is found in being part of the fabric. You are woven into the same tapestry as the galaxies, the same story as the stars. Expansion is not something that happens outside of you. It is something you are made of. And then comes the third meaning, perspective. Expansion changes how you see time. Not only cosmic time, but your own. Your life feels short, fragile, fleeting. Against billions of years, what is a single lifetime? Against trillions of galaxies, what is a single being? But expansion reframes this. Yes, you are brief, but you are brief in the way a sunrise is brief, or a song is brief, or a breath is brief. Briefness does not erase beauty, it sharpens it. The universe expands, and in one small corner of its unfolding you exist. That is not meaningless, that is miraculous. Expansion also changes how you see struggle. Your worries, your fears, your ambitions all feel enormous in the moment. But against the backdrop of galaxies drifting for billions of years, they soften, not because they are unimportant, but because they are temporary. Expansion gives you perspective. It reminds you that nothing is fixed, nothing is permanent, nothing is forever, and that reminder can be freeing. Because if nothing is fixed, then you are free to change. If the universe itself is restless, you can be restless too. If the cosmos grows, you can grow too. Expansion becomes not only a scientific truth but a personal lesson. Change is not failure, change is life. And then comes awe. Awe is what happens when humility, belonging, and perspective merge. Awe is what you feel when you realize that the universe is vast beyond measure, yet you are woven into it. Or is what you feel when you understand that expansion is not only real but knowable, measurable, comprehensible to the human mind. Or is what you feel when you accept that you are both small and infinite, fragile and eternal, a flicker of consciousness carried on an expanding tide. Or is the synthesis itself. And awe does something to you. It changes how you move through the world. It softens the edges of fear. It quiets the noise of daily life. It gives you a stillness, a calm, a sense of being part of something larger than yourself. Expansion is not only a cosmic truth, it is a meditative truth, a truth that can cradle you, soothe you, carry you into rest. So when you lie awake at night, restless thoughts circling, worries sharp, you can turn to expansion. You can imagine galaxies drifting, space stretching, time unfolding. You can remember that your breath is born of hydrogen older than stars. You can feel yourself carried in the current of expansion, part of a story too vast for worry to break. And in that remembering, you can find rest. This is what it means to live in an expanding universe. It is not only to know the science, though the science is precise and strong. It is to let the science shape your perspective, your sense of self, your way of being in the world. It is to find humility, belonging, perspective, and awe. The synthesis is not an answer. It is a way of seeing, a way of living, a way of being carried by expansion not only in space but in thought. And from here, the synthesis will go deeper still, into the nature of time, into the mystery of beginnings and endings, into the open loops that expansion leaves, questions unanswered, horizons unreachable. Because the story of expansion is not closed, it is not finished, it is ongoing, still unfolding, still stretching. And so are you. The universe expands, you know it in evidence, you feel it in meaning. You have carried it through intuition broken, counter cases fallen, synthesis woven. And now, in the quiet of reflection, you can let expansion unfold not only as knowledge, but as vision. Close your eyes, if you will, and imagine, not one galaxy, not one cluster, but the whole. Imagine the universe as far as you can stretch your thought, galaxies scattered like jewels on velvet, spirals and ellipses glowing, clusters bound together like constellations of constellations. Imagine them not fixed but receding, each carried by the invisible tide of space. Now zoom farther still. Imagine billions of galaxies, each with billions of stars. Imagine their light rushing outward, their distances growing. Expansion is not slow. It is relentless, steady, patient, carrying all of creation with it. And now go farther to the edges of what you can see. 13 billion years of light stretched and thinned, the faint horizon of the observable universe. Beyond that horizon, more galaxies, more stars, more expansion hidden forever from your sight. Expansion ensures that much of the universe will remain unseen, unreachable. Most of reality is beyond you. You live inside a bubble of light, surrounded by horizons. And yet within that bubble, you know enough to grasp the whole. You know the laws that govern. You know the patterns of redshift, the whispers of the microwave background, the fingerprints of helium. You know the expansion not only exists but accelerates, driven by something unseen. You know even from your small corner the sweep of the story. This knowledge is astonishing. A fragile being, alive for a few decades, standing on a small planet, can comprehend the drift of galaxies across billions of years. Consciousness has expanded with the cosmos, thought stretching to match the vastness of space. The mind is a mirror for the universe. And in that mirror, expansion reflects back. But vision is not only about knowledge, it is about meaning, and expansion carries meaning too. Because expansion tells you that the universe is not fixed, it grows, it changes. It has a history, a future, a story. And that story is not only about stars and galaxies, it is about impermanence itself. Everything changes. That is the truth. Expansion writes across the sky. Galaxies drift, stars ignite and die, light stretches into silence, matter itself decays, there is no permanence, there is only becoming. And yet within that impermanence there is beauty. The galaxies exist because of expansion, the stars burn because of expansion, life breathes because of expansion. If the cosmos had been static, none of this would have unfolded. The instability, the restlessness, the impermanence, that is the condition of creation. This is the paradox expansion reveals. Permanence is not loss, permanence is possibility. The universe expands, and because it expands, it can hold galaxies, stars, planets, and you. And so, in the vision of expansion, you find a way to hold your own impermanence. You too are temporary, you too are a flicker, but that flicker is no less beautiful for being brief. It is beautiful because it is brief, like a star, like a galaxy, like the universe itself. Think of the hydrogen in your body, born in the first minutes of time when the universe was still fire. That hydrogen has lasted billions of years, carried through stars, through galaxies, through space until it became you. When you breathe the earliest chapter of expansion. Think of the carbon in your cells, forged in a star, carried outward in a supernova, scattered across space, gathered again into a planet, into a body, into thought. When you think with matter made in fire, carried by expansion. You are not separate from this story. You are the story, a brief chapter, yes, but a chapter woven into the whole. And now expand your vision farther still, beyond galaxies, beyond clusters, beyond the observable horizon. Imagine the universe not as an object, but as an ocean, infinite in its reach, restless in its growth. Imagine it swelling, stretching, carrying all of existence in its tide. Imagine it as something you are inside of, something you are made of, something you are. And then ask yourself, what does it mean to exist inside such an ocean? It means to live with awe, to live with the knowledge that you are small, yet not insignificant. To live with the understanding that you are temporary yet not meaningless. To live with the recognition that you are woven into the same fabric as galaxies and stars. It means to live with perspective, to see your worries, your struggles, your ambitions against the backdrop of billions of years, trillions of galaxies, to let them soften, not vanish, but find their place. It means to live with humility, to know the universe is not built for you, not centered on you, not designed around you, and yet somehow it includes you. Somehow it creates the conditions for you to exist, to think, to wonder. It means to live with belonging, to feel yourself not as an outsider but as part of the whole. To know that your atoms are ancient, your body is cosmic, your mind is an echo of expansion itself. This is the ultimate synthesis. Expansion is science, yes, but it is also philosophy, it is also meditation, it is also a way of being. And perhaps that is the point. The universe expands, and so must you, not only in knowledge but in awareness, not only in thought but in perspective, not only in science but in spirit. To live in an expanding universe is to live in a universe that asks you to expand with it, to stretch your mind, your vision, your compassion, to grow beyond the limits of instinct, to imagine beyond the boundaries of comfort, to see yourself as part of something larger. Expansion is not only a fact of the cosmos, it is an invitation. And here at the height of synthesis, you can feel that invitation. You can feel yourself carried outward, not only in space but in thought. You can feel yourself woven into the tide, part of a story larger than imagination. This is expansion, this is the universe, this is you. And from here the journey bends again, from synthesis to mystery, from knowledge to open questions, from certainty to awe. Because expansion answers much, but it leaves much more unanswered. What is dark energy, the force behind acceleration? What came before the beginning? What lies beyond the horizon? What does it mean for time itself to have a birth? These are the open loops, the questions that cannot yet be closed. And those loops are where wonder lies. The universe expands, you know it now in science and in meaning. The galaxies drift, the background glows, the elements testify, the structures ripple, the supernovae stretch time itself. The counter cases have fallen, the synthesis is woven. And yet, as the story nears its end, you find yourself circling not answers but questions. Questions that resist closure, questions that remain open, questions that point beyond what you can know. This is the open loop. Because expansion does not answer everything. It opens mysteries larger than itself, mysteries that leave you suspended, thoughtful, awake in wonder. The first mystery is dark energy. You know the universe expands, and you know that expansion accelerates. But why? What force stretches space faster and faster, overwhelming gravity itself? The name dark energy is a placeholder, not a solution. It says only something unknown drives this acceleration, something unseen, something we do not understand. Is dark energy a property of space itself, a constant pressure built into the fabric of reality? Is it a new kind of field, invisible and strange? Is it an illusion, a sign that our understanding of gravity is incomplete? No one knows. The data insist, the measurements confirm, but the meaning remains elusive. And the implications are staggering. If dark energy persists, the universe will not only expand but accelerate into emptiness. Galaxies will vanish beyond the horizon. Stars will fade. Matter will thin. A cosmos blooming now will cool into silence. Expansion is not only story, it is fate. But if dark energy changes, the fate changes too. Perhaps acceleration will slow. Perhaps gravity will win, pulling the universe back into collapse. Perhaps cycles repeat, expansion, contraction, rebirth. Or perhaps something stranger awaits, something no theory has yet imagined. This is the first open loop, the future of expansion, written in evidence but unfinished in meaning. The second mystery is the horizon. The universe you see is not the universe entire. You live inside an observable bubble, 13 billion years of light in all directions. Beyond that horizon, more galaxies, more space, more expansion. But you cannot see them, you will never see them. Expansion carries them away faster than light can bridge. Most of the cosmos is beyond your reach forever. What lies beyond the horizon? Is the universe infinite? Does it curve back on itself like the surface of a sphere? Does it stretch endlessly, or does it fold into shapes you cannot imagine? You do not know, you cannot know. The horizon is not only a distance, it is a wall of knowledge. And yet you feel the pull of the question. You cannot help but wonder what lies beyond what you can see. You cannot help but imagine the unseen, the unreachable, the hidden vastness beyond your bubble of light. This is the second open loop, the shape of the universe itself, known in part, unknown in whole. The third mystery is the beginning. Expansion tells you the universe once burned hot and dense. It tells you time itself had a beginning, or at least a moment when it became measurable. But what came before? What lay behind the birth of time? Perhaps nothing. Perhaps the question dissolves, like asking what is north of the North Pole. Time began and there was no before. Perhaps the question is meaningless. But the mind resists that answer. It craves causality, sequence, origin, and so theories arise. Perhaps the universe emerged from a quantum fluctuation, a seething foam of possibilities collapsing into something real. Perhaps it is one bubble in a multiverse, one expansion among infinite expansions. Perhaps cycles repeat eternally. Perhaps something unimaginable lies behind it all. But all of this is speculation. The evidence cannot yet reach back that far. The earliest seconds are hidden, veiled by conditions too extreme for present physics to pierce. The beginning remains a mystery. This is the third open loop, the origin of expansion, known in trace, unknown in essence. And then the fourth mystery, meaning. What does it mean to live in an expanding universe? What does it mean to know that the cosmos has a beginning and an end? What does it mean to exist in a reality where impermanence is not failure, but law? Science does not answer this. Philosophy does not finish it. Religion does not resolve it. Meaning is the open loop that belongs to you. You must choose how to live with expansion, how to let it shape your vision, how to let it guide your sense of self. Some find despair in it. They see only impermanence, only endings, only silence. Some find awe in it. They see beauty in impermanence, story in change, belonging in being part of the whole. Some find mystery in it. They let the questions remain open, carrying them like lanterns into the dark. Perhaps the point is not to resolve meaning, but to live with it, to let expansion expand you, to let it stretch your sense of self beyond instinct, beyond comfort, beyond certainty, to let it carry you into awe, even if awe is unresolved. These, then, are the open loops. Dark energy, the unknown force driving acceleration. The horizon, the unseen universe beyond reach. The beginning, the mystery of origin. Meaning, the reflection of it all in you. They do not close, they cannot close. They remain open, waiting, unanswerable for now, perhaps forever. And that openness is not failure, it is wonder. Because to live in an expanding universe is not to live in certainty. It is to live in mystery. It is to live knowing much but not all. It is to live inside a story that stretches beyond imagination, with chapters unread, horizons unseen, questions unresolved. And perhaps that is the gift. To live with open loops is to live awake. It is to let the universe remain larger than you, stranger than you, more mysterious than you. It is to let awe be your final answer. So here you are near the end of the journey. You asked, how do we know the universe is expanding? You followed the evidence, the counter cases, the synthesis. You arrived at certainty, and then certainty opened into mystery. That is where you rest now, not in closure but in awe. And as the story moves toward its final part, the loops remain open, the questions echo unanswered, and the wonder deepens. Because the universe expands, and the mystery expands with it. The universe expands, you know this now. You have followed the light of galaxies, the whisper of the microwave glow, the chemistry of helium, the clustering of galaxies, the stretch of supernovae. You have seen the counter cases rise and fall. You have felt the synthesis, the weaving of science into meaning. And then, just when you thought you had arrived, the open loops appeared. Dark energy, the unseen driver of acceleration. The horizon, the unreachable beyond. The beginning, the mystery of origins. Meaning, the reflection inside yourself. Questions without closure, truths without answers. And so here you are at the end of the journey. And yet, it is not an end at all. It is a drift into wonder. Because the universe itself is not finished. It expands still, carrying galaxies farther, stretching light thinner, cooling the cosmos with every breath. The story does not close. It continues outward, onward into mystery. So let yourself rest in that openness. Imagine the night sky again, stars scattered like diamonds across black velvet. But now you know the secret they carry. You know that they are not fixed, not eternal, not still. You know that the space between them grows, that their light is stretched, that their future is to drift away into silence. But instead of sorrow, feel wonder. Wonder that you can know this. Wonder that light, traveling for billions of years, reaches your eyes, carrying the story of expansion. Wonder that your body, your breath, your very being is made of atoms born in the furnace of that expansion. You are not outside this story. You are not a spectator looking in. You are inside, carried with everything else, woven into the same fabric that stretches. The hydrogen in your blood is as old as time itself. The oxygen you breathe was born in stars lit by expansion. The thoughts you think are shaped by a brain built of cosmic matter itself arranged by cosmic history. You are not separate. You are the universe, briefly awake, aware of itself. And yet, even as you know this, the questions remain. What is dark energy? What lies beyond the horizon? What came before the beginning? What does it mean to exist at all? You do not know, perhaps you will never know, perhaps no one will, and perhaps that is the point. Because mystery is not failure, mystery is invitation. Mystery is the space that expansion leaves inside you, a widening of thought, a stretching of imagination. Mystery is what keeps you awake, what keeps you curious, what keeps you wondering. And maybe in the quiet of night that is enough. Not answers but wonder, not closure but openness. The universe expands and you expand with it. Your thoughts stretch to meet it. Your perspective widens. Your sense of self softens, dissolves into the whole. And so at the end, you find yourself not with resolution, but with calm. Calm in knowing that impermanence is not loss. Calm in knowing that beginnings and endings are part of story. Calm in knowing that expansion is not something to fear, but something to embrace. The universe expands, and so can you. You can expand in thought, imagining beyond instinct. You can expand in perspective, seeing yourself as part of the whole. You can expand in awe, letting wonder carry you into silence. And perhaps, as you drift into rest, you can carry this with you. That the universe is larger than you can imagine, stranger than you can picture, older than you can fathom. That you are small within it, but not insignificant. That you are temporary within it, but not meaningless. That you are expansion itself in human form. The galaxies drift, but you drift with them. The light stretches, but you stretch with it. The story unfolds, and you are written inside it. So let the questions remain open. Let them echo in the silence. Let them carry you not to resolution, but to wonder. Because the universe expands.